Any questions? You good? What's that?
I got like.
That's where you put everything, all the X and Y on one side. I'll write it up in a second. Each of these forms, they each have their uses, and some have their uses in some places and others have their uses in other places.
Slope intercept.
Mhm. I don't know what, hold on, let me.
We're taking the line. How that must be. I'm using it into.
That happens, sure, that can happen, yeah. Usually, the substitution method is good when one of the variables, one of the letters is already solved for.
Just plug in that one letter.
Let's see, this is page 6. Standard form looks something like this. This looks like something like this. So they're all on one side. And then the one that we like to graph with. This one is always going to be the more useful to us, usually. Are there any math problems you'd like me to do?
Yeah. There was one that it was 5x plus 2y. It was on the substitute and get the x and y.
Sure. Let me grab it. Five, 1, and 5, 2. Or 5 and 9, 3. Oh, there we are. 5, 1, and 5, 2. 5, 3. Okay.
Like 19, I think.
That thing?
No, not that one. The problem was 5x plus 2y equals 7x minus 3y equals 15 for.
Does it look like this?
Substitute. Yeah, it looks something like that, but it's a different one.
Yeah, they'll change the numbers. So if they're all on one side like that, this is not the best method. Substitution is not the best method for doing them if they're like this. But it will work, but it's not the best. We'll learn the best way to work with that today. So are you in there? Paste. The problem with it right now is that you have to find out where you have to pick one of these to solve for to make it so you can substitute it in. Scan and look at everything you have there. Does any of these look like it would be pretty easy to solve for one of the variables all by itself? The top one looks easier, doesn't it? So before you do anything, I would take and rearrange this top one so that it looks like this. So this one I'm going to change to y is 2x plus 1. I'll pause there. Follow what I just did? So to use the substitution method, you have to do something like this first. You have to make sure that you solve for one of the variables all by itself. And then you're going to take that and plug it into. You're going to take this guy here. We're going to plug it into here. Yeah. Well, you got to add it. 2x.
So we're all putting this to the one.
Yeah, of course, yeah. I need to get y by itself. So now when I work that equation, I'm going to have negative 5x plus 3 times 2x plus 1. That equals 5. And this is desirable because we can only solve equations that only have one letter in them. So since we only got x, we'll be able to solve for it nicely. Let me go ahead and multiply everything out. Make sure you can follow what I just did. You guys follow all that? Okay. Well, look at this. Do you see what's going to happen? The x's are going to be pretty nice to us. Negative 5x plus 6, it's just x. And so x is going to equal 2.
Subtract 3 to get 2. What x? So
1x is the same as x. I guess. Yeah. All right. So we have x equals 2. And then if I want to get y, what's the easiest way to go back and get y? Plug it in for x, but the easiest place is going to be where you already solved for y. So you're going to use the equation y equals 2x plus 1, and you will replace that x with a 2. And so my y is equal to 5. Let me see something here in this book. The textbook doesn't always use a notation that is pretty standard, so I want to be careful. Yeah, this is well, what are my answers? 2 and 3? 2 and 5? This is really not the way that any answer is given for these kinds of problems. The way that the answer should usually be. I mean, you do say the x and the y. That's what I mean. In every book besides ours, the actual answer is written this way. The answer is usually written as an ordered pair. But it's okay, your books, you still recognize that x is 2 and y is 5 with that answer.
So I need you to run over this one because I didn't have a lot of problems with one set up like that. It was this specific one that I can't have. That had an issue.
So you're saying the one I did is not the one you had an issue with?
No, like it's set up like that. The ones that came that it was just like this one problem was specific how it was set up. I don't know. I couldn't completely figure out what it was.
I mean, there's.
It was definitely one of the last two. I might have just got a different set on the last one.
I see there. This is totally different. What do you mean fully up? See, I have to actually do something to try to get one that they want, that I like.
Right.
If you have it written down, I'll just write it up. They could take days to just, they say, let me just point it.
5x plus 2y equals 7.
Okay.
And x minus 3y equals 15.
Now here, can you tell me which of the two letters is it easier to solve than get by itself, do you think? It doesn't always have to be one, but is there one that's gonna be easier?
Probably
The second equation, I'm eyeballing that x. And I'm thinking the easiest thing to work here is that x is gonna equal 3y plus 15. So far, so good. So if you see a chance like that, it makes life easier for you.
that's what I did. I feel like I see the bill I actually did wrong with that too, right there. Because I did it the other way. I got the y by itself.
You wanna do it just to be like rough on yourself? We can. But this is easier. What I'm saying is, you look at the letters, if I see that any variable is by itself, that's the guy I'm gonna target. But then doing it this way, what are you going to do with that?
You just don't flip that in for the x.
We're gonna take this guy right here and put it into, you always gotta do the other equation. If you made the mistake of trying to put it back into the same equation, if you do everything right, you'll get something like 0 equals 0, and it will be useless. All right, so let me go ahead and put in my numbers, my letters. I have 5 times 3y plus 1 plus 2y equals 7. I'm going to multiply through the 5. 15y plus 5 is 2y equals 7. Looks like 17y plus 5. 7. So we're not even gonna get a good answer here. It's too bad. I don't get it. The homework, like some of the problems are pathetically easy, but the same one, you can choose one that is hard. So anyways, let me get this. I get 17y equals 2. And then if I divide by 17, I end up getting y equals 2 over 17.
So all we did was plug in x, right?
That's right.
So why not? 3y plus 1 would be 3 over 17. Yeah.
Oh, did I make a mistake? Yeah, okay. I did that.
I was lost after that. I could.
Well, if it's wrong, then I don't blame you. 15. So then,
Does that change a lot?
yeah, it does. This is gonna be a 45. Bet your answer's not a fraction anymore. Let me not keep sneaking it in.
What? Isn't 5 times 15 75?
Yes. Well, subtract 75 and I'll end up getting negative 68. Of course, it changes everything over here. What is 68 divided by 17? You get negative 4. All right, so there's our y. Then the easiest way to take and get x is to take it and plug it back into the equation to solve for x. So we had X was 3y plus 15. So I'll replace the y with -4. And that looks like I'm gonna get an X is equal to 3. X. So my answer then, X was 3, Y was -4.
Simple mistake, I throw it all.
Well, you didn't make a mistake. What you did is you just took a bit more difficult path. Let me rewrite it up. 5x plus 2y equals 7. And we'll purposefully do it in the least efficient method possible. Regardless of do-over. Five x plus 2y equals 7. What was the other one? X minus
3y equals 15.
So now, we're going to take a more difficult path and solve the second equation for y. All right, so the first thing that you would do on this equation then is you would subtract x from each side. Right? I'm going to divide both sides by -3. So you're solving for y. That's not bad. Did you get this for your y? Yeah. All right, so then I take this guy here and plug it into the other equation. So let me get this solved for y. So it's got to go into that spot. So we have 5x plus 2. Now I'm going to replace the y 1/3 x minus 5. When you do your substitution, you should put it in parentheses or something. It's not going to be good. Are we good so far? Now I'm going to distribute that 2 through. And I get 5x plus 2/3 x is 10 equals 7. So good?
Yeah. Or whatever I did wrong.
We're going to add 10, so I'm going to combine the x's first. So remember this 15, this x is 15/3 x plus 2/3 x minus 10 equals 7. I did the 15/3 so they would have a common denominator. I can combine my x's now. So I get 17/3 x. And now, what are we doing now? Add 10, both sides. So you'll see 17/3 equals 17. This is real, oh, where's my opposite? What I would do at this stage is this. I would multiply this side by 3/17 and do the same on the other side. You can see the 17s are going to wipe out.
There it goes. I forgot to put the residuals.
X equals 3. So then your y was equal to 1/3 x minus 5. So we have 1/3 times 3, or if you want 3/1, and that'll end up being -4. I do not remember. Did we get that last time?
Yeah, negative 4 and 3.
No, 3 is
Yeah,
first.
3 is first. Okay, 3 and negative.
The order matters here, that's what I said.
Okay.
Other questions, other problems that you'd like me to do? Do you see the 1/3 times the 3/1 down at the bottom?
Yes.
That's equal to 1, all of that, right? What's 1 minus 5? You okay or no?
Yeah.
All right. What I'm gonna use your problem to do the next method that we have, which is the method of elimination. Before I do it though, I wanted to make sure I had all questions exhausted. That includes you WebEx folks. Assuming my voice is here. I don't even know if this helps them or if it's just for me to help, but we'll turn that up. Okay, well then we'll go on to, I think, what is my section today? 5.3. And it is, I believe, called the elimination method. Now, just like the substitution method, this method is capable of finding any solution. So really, if you had to live with the solution, I would pick either the substitution method or this one. Because graphing only works in very specific cases, yeah.
Which one preferred by most students?
I don't know, there's not. What happens with most students is they do a combination of the two. I'll show you how. Let me see what the problem is that we just had, because I want to grab it again, but I keep writing over the thing. 5x plus 2y equals 7. I think it was x minus 3y was what?
15.
This method doesn't involve trying to do any kind of manipulation that we did before. What you do now is, the method is elimination. That's exactly what we're going to try to do. Watch what I do. Now, before you say why, just give me a second and I'll explain. I'm going to explain all of that. But I'm going to multiply the second equation by -5. That transforms the second equation. Let me leave the first one as it was. But the second one, when you multiply everything by -5, you get this. Is that correct? Why did I choose -5? Now it will become evident. I add these two equations together. What happens to the x's? What is 2y plus 15y?
17.
7 plus -75.
82.
Right.
62. 68. Yeah. I want that.
Then to get the y value, what do I do?
It's the virus.
Divide by 17. So y, as we know by now, is -4, isn't it? Now we go back and redo the same thing again. But instead of making the x's go away, I want the y's to disappear. So let me write this, repeat. For x. So I rewrite the entire problem again. Now, I should tell you that higher level, the more you progress in math, the less the problems will become what they call root problems. That means you do the same set of steps every time you solve a problem. These problems are getting more difficult. That means they require you to not just mechanically solve, but to actually read and look and understand what's going on. Now, what I want to do is make the y's go away. Last time, I saw that I had a 5x and an x, and I go, well, if I had a negative 5x, I could wipe them out. But look here. This y is a 2, and this y is a negative 3. If I add these together, the y's are not going to eliminate. But I can do something very tricky. I'm going to multiply the first equation by 3, and the bottom by 2. This makes, if I do both equations, the first equation is 15x plus 6y equals 21. Make sure you multiply the 3 to every single thing in those parentheses. And then for the second equation, I get 2x minus 6y equals 30. Look at the y's. You see that one is a positive 6y and one is a negative 6y. When I add them together, what's going to happen to those y's? They're going to eliminate. Right, exactly. Add them together. And now we've made the y's disappear. Now I can divide them by 7. Well, I know I got to get a 3, so I knew it wasn't something was up. When I divide by 17, I'm going to get it by 3 that I knew to get. So you get x equals 3 here as well. So the elimination method is a little bit different. Although, did you notice that a lot of the numbers that were appearing when I solved it appear in the other ones too? 17 was appearing all the time. So they're closely related. What I want you to do is be able to look at a pair of equations and go, which one will be more efficient, this method or this method? That would be ideal. So we're going to grab a bunch of problems to get you comfortable with it. I did not grab the easiest problem right off the bat, so this makes, hopefully this will be an easier section for you, but here's with one of the original starting problems that I would give you. Looks like this. Now, here's how you approach these problems. Look at the parent. Can be eliminated without doing a single thing. Without doing anything. So what do we do? So if you got anything that eliminates right off the bat, do it. These y's go away and I get 7x equals negative 21. All right, then what are you going to get for x? Divide by 7. Well, yeah, you get x equals negative 3. Now, I highly recommend you rewrite. Yeah. All right, I've already wiped out the y's once. I don't need to do it. Now I got gotta wipe out the x's. Tell me how I can do it. Right. I'm gonna take this 3 and put it here. I'm gonna take this 4 and put it here. Do you see that when I've done this, I'm gonna have 12x and 12x? Gotta make one of them negative though, don't I? 12x and 12x doesn't eliminate, does it? So pick one of the ones to be negative. Either one. I'm going to choose my negative to be the second one. Once you multiply the entire equation by that number, it's still good. So yes, I can multiply by whatever number I want, as long as I do it to the entire equation. So now, I get, for the first equation, I get 12x minus 3y is negative 45. And then I get negative 12x minus 4y equals 24. Now I'll add them together, and as we made it work, as we forced it, the x's will disappear and we'll get negative 7y, negative 21. So what is y? So I got a negative 3 for x and a positive 3 for y. This problem could have been done by graphing easily. Both of those would have been solved for y. But also, another thing this book does that annoys me a little bit is these answers usually come out to be nice, good answers. But that totally ruins the whole idea of having this method in the first place. This method's supposed to take care of anything, including fractions. So before we get done, I'll have to make up some of my own.
It's elimination, right?
That's a limit. That's the whole section is elimination. Yeah, that's why we're on a new section. So let's do one a little more complicated. Seven x plus 6y equals 3. X plus 2y. All right, does it look like anything will wipe out right now? Add them together, the y's don't go into the new x's. Nothing's gone right out today. So we're gonna have to work on this one. I'm going to attack the x's first. So tell me, what number should I multiply so that I can get the x's to go away? What would I multiply the first equation by? 3. That 3 comes from the second equation. This 3 right here, I'm going to multiply. So right, I'm going to take this 3 that's right here, put it out there. So I get 3 times. Now, what are you going to do for the bottom part? What are you going to multiply down here? Let me put 7 before I can answer. All I do is swap the 3 and 7.
I got that part.
I get they're both 21x. Keep one of them to go away, so pick one to be negative. I don't care. Either or. You can pick, I usually pick the bottom one. Okay. You can find out one. Okay. So this equation, these series of equations then become negative 21x minus 18y equals negative 9. Positive 21x plus 14y equals negative 7. So now the x's will eliminate. So we end up with negative 4y equals negative 16. And if I divide by negative 4, I get my y. Now rewrite the equation so that you can wipe out the other variable. All right, now I want to take out the y's. Can you tell me what I could multiply by to make that happen? Top one is 2. And the bottom one is 6. So that when you multiply that through, you're going to get a 12y for both of them. Which one do you want to be the negative? There's no, it really does not matter. Top, we have 14x plus 12y equals 6. And for the second set of equations, I get negative 18x minus 12y equals positive 6. So those y's wipe out. What do we add them together? And I end up with negative 4x equals 12. And so what's x going to equal? Negative 3. That's right, yep. So our answer is negative 3, negative 4. What's up? Okay, let's make it a positive. Negative 3, positive 4. But so we got the idea here on wiping them out. Let me look for something that doesn't have as joyous of an answer as these other ones. Although your book does not work hard to make problems tough for you. Minus 4y 7. 12x minus 3y. Anybody think they got the answer? What'd you get for Y? That's good.
Is it actually?
Negative 13 is correct. We'll repeat the same process to get X. No. Well, yeah, you gotta try to get the same. Right, exactly, right. I doubt, I'm sort of interested. Did anybody do this to wipe out the X's? Did you multiply the first equation by 6? The second equation by -5?
Yeah.
I bet you did 12 and 10, huh? You know why I chose my numbers? What's 6 times 10? What's 5 times 12? They still work, don't they? So you have complete freedom in this regard. I have 60x minus, I don't erase this because that's not the way the regular student is going to do these things. Most people are going to put all up here and a negative. So that we get 120x minus 48y equals 80. And negative 120x plus 30y equals 150, correct? And when I add them together, the x's are gone. It looks to me like I get negative 18y. 230. Divide by negative 18. I believe that does come out to be y equals negative 13. One of the reasons people don't like doing this method is because there's a lot of writing involved. But it was interesting. I know when I was a student that when I would go to a math class, many times my wrist would be sore when I would walk out of there. So I got asked by what happens when your arm gets sore when you teach? I go, one way. When I became a professor, it just disappeared. It's cured. All right, how about the Y's? How do you wipe them out? Anybody? Okay, you did negative 3 on the first one, and then positive 4 for the second one. As long as you get a 12 and a negative 12, that's all that matters. So I have negative 30x plus 12y equals negative. And then we have 48x minus 12y equals negative 60. Let's add them together. I get 18x equals 1. Good so far. Now I'm going to divide by 18. The only thing that goes into this here is 9. So you're left with negative 9 over 2. And there we are. Well, the whole point of these things is if everything worked well and was graphable, we wouldn't even bother with these methods. Because graphing's got to be more fun than this. We have negative 9s for x, and then with y, we're to go negative 13. The whole point was that these methods can handle any kind of an answer, even the ones with fractions. Say again?
The other night at home, I'm trying to figure out how some of the graphs work when you got fractions like that. It was annoying to line them up properly.
You can deal with fractions to some extent. Like if you want to deal with halves, what you can do when you graph your paper, each marking is 2 marks. That way you have a half mark. Or if you had thirds, you would do 3 to make 1 unit, you know what I'm saying?
Right.
But it takes a lot of graph paper if you're dealing with like 10 or 20 or something like that. All right, let's go ahead and take a break there. You're gonna want, I don't know what you're gonna do to come back, get ready, prepared for what's going on, but we're gonna do word problems when you come back. Well, you are, after this, you can pick whatever method you want to solve these systems. So you can use whatever you want, but you'll have to use some method for the word problems that we're gonna get.
question.
Hmm?
What is proof of limit with the nth root of x?
Nth.
And
Yeah, it's popular video. I just found out.
yeah,
Kids love it.
that's something you actually teach? Like,
Actually, that, I put it for my calculus students. But it's actually more advanced than I normally teach in that class.
yeah.
So a lot of the students are looking at that are like senior level math or graduate level students. Here, the world. Virtual. There we are. There it is. How many times? Okay. also mention something. I mentioned that 2 years ago, when COVID started, our courses were cut in half. So I did the rest of the course online, but I made up videos. That means, as you've been looking for videos, I have half of this course, the videos are in YouTube, and you can go in Blackboard, I have the progresses of all of them. But I think they could be very useful for helping you, especially if you forget something, something like that. The whole lectures are online as well. Okay?
Do you ever post, like when you review tests, like older tests, you don't post those, do you? Like we review.
I put the review up. I mean, this lecture today will go up online. It'll just look like the WebEx. I've seen them, but they're not as pleasant to look at. As the other ones, all you see is my writing or graphs, kind of what I'm doing on the paper, maybe a calculator or something like that. So they're much better as far as getting the material across. The beauty of, I think, having them on video is that you can sit and pause and fast forward or do whatever you want to get to where you want to go. One of the people who read one of my first lectures, a guy put on there, he said to change the speed to 1.5 times because I talk too slow. So you can he said, do yourself a favor. Put it at 1.5. All right. There's no pleasant way to get into these things. I know that. But most students are usually like, what are the purpose of the math that we're doing? Well, I mean, there are some real world problems we can solve with this stuff. Do I want that thing? No. You know, since I might as well just grab from the homework because you guys are going to be working that anyways. And I want to focus on those problems anyways. So let's pop into, I just made this up. So we'll go into preview. Well, wait. Now, granted, this kind of a word problem is not exactly the one kind of a problem you would find in a real life situation, but it's meant to warm us up anyways. So this will be my first example. The sum of two numbers is 56, and you can see you can write equations here underneath if you want to. Let's do, what are the numbers? So what I'm going to do is this. I think I'll go X will equal a smaller number. Larger number. Let me cut, at least break this question up into parts so that we can tackle each part separately. So I'm going to start this part right here. That's an equation that they just listed there. Did you know an equation is a sentence? Does everybody know that? The equal serves as the verb. So here we have the sum of two numbers. The sum of two numbers is 56. Can you give me an equation for that? X plus Y equals 56. It's very simple. So the stuff that we did earlier in the semester where we were doing these sentences and all that does come in handy too. Now there's another sentence And that's this one over here. Look over here. Can you give me an equation for that sentence? What is the larger number? Right. So under larger number is y, right? No, don't do that. It's, you read it right off the page. You have the larger number. We already know that this is y. Tell me, what does the word is mean? Now, what does the other side of the equal say? 20 more than the smaller number. So in this easy problem, they literally wrote their own sentences. So in case we need a synopsis of what we did, here's our two equations. I have x plus y, 6. And y is 20. Substitution or elimination, I wouldn't recommend graphing for anything like this because the answers could be anything. Any suggestions? I think substitution is easier because I can take the 20 plus x, plug it right into where y is. Like this y is solved for it. Substitution makes sense to me. So that 20 plus x is going to go into that y. So let me rewrite that first equation. We have x plus, instead of y, I got my 20 plus x. And that was equal to 56. Now you can solve this as you would any other equation. I'll combine my x's. I get 2x plus 20. What next? Subtract 20, so I'm going to get 2x equals 36. Divide by 2, x equals 18. So I got half of the answer. How do I get the value of y? You remember, y was already solved for. So you would be very inefficient not to use that particular equation to get your answer. Remember, 20 plus x. Does that look plus? Looks like some horrible x. But minus x. And if I replace the x with 18, I'll get y equals 38. So they'll probably have a boxes for you. They'll need you to say which is the smaller. Which is, well, I think it's over there, isn't it? I literally pulled it off of the homework. The larger number was y. And the smaller number was x. That was what, 18? You can tell if you're going to be right before you ever do this, if you plug them into the equations and they both work. Remember how to check yourself? Other questions about that? Yeah.
So you chose which one was smaller, which one larger?
Yeah. It doesn't really matter. You just got to say, I've got to make a space for a smaller one and a larger one, because it makes mention of that in the problem. So it kept talking about larger and smaller. If you want to, you can use letters that are more useful to you. Like I was tempted to use the letters L and S for larger and smaller. That makes it, most people, when they do, if you go on to do anything mathematical, scientific, or something like that, most people pick variables that will remind them why they used what they did. So I may do that for one of these, or I'll pick useful letters instead of always just X and Y. But some students get freaked out when they see letters other than X and Y. So my task is complicated here. And keep in mind, there's always more than one way to do with these problems, so that further complicates things as well. So a store is having a sale on trail mix and jelly beans. We have 5 pounds of trail mix and 2 pounds of jelly beans, and they've got the cost. And then 3 pounds of trail mix and 8 pounds of jelly beans, they have the cost. So what if I did this? You tell me. It's right here. It's an equation, but you may read it as a sentence, which is the same. I actually wanted to bring it down. The one thing about mathematical word problems that you have in class, you have all the information you need. It may not seem like it, but you do. All right, this led me to an equation right here. Let me show you what I'm talking about here as far as the letters are concerned. Right there. Does it make sense what I did? But I didn't even say what the letters are. Do you understand what the letters are standing in for? That's why using useful variables is very helpful. Your book or wherever you go to will use X and Y for everything. And I think that's not a good idea. That's certainly not what people do when they go into higher level classes. And then I had a second equation, which I'll grab that and put it right under this one. Now, using my letters, can you give me an equation for this sentence? What is it? That's right, 3t plus hj equals 21. I should have mentioned this. By allowing you to use more than one variable, these word problems become easier than they were when we did them in the semester. I don't remember we did one like this, but now I have a system of equations. I'll go ahead and I'm going to rewrite them because I'm going to solve them. So between the two of these, what method do you think is going to be the easiest way to solve this? Elimination. No variable is alone. So let's wipe out the t's first. Tell me how to take out the t's. 3 and 5, so 3 on the first one, 5 on the second one. That way both of these are going to give us a 15t, but now I need to wipe out one of them, so give me one of them read negative. Put the negative with 5, fine. So when I rewrite these equations, first one is 15t plus the 6j equals 54. Negative 15t minus 40j is negative 105. And now we can wipe out the T's. I'll divide by -34. Or you can use your calculator. Why would I suggest using a calculator on this problem? Why am I using a decimal in this problem? That didn't work. Talking about money, come on, something costs, right? You ever go to the store and buy something for $300? Although some of the things they put up on signs, you can spot arithmetic errors all day long. But this is actually equal to 1.5. I want decimals because we are talking about dollars and cents. So I actually want $1.50. I think that was per pound of the jelly beans. Now remember, to get rid of the other variable, you rewrite the equations again. 5t plus 2j. 3t plus 8j plus 20. 21 that turn here. Now what numbers would you use to wipe things out this time? That's all I would do too. But what are everybody else going to do? They'll do 8 up here and 2 down here. There's no reason, there's no harm in doing it. And plus, if you want as root of a method as you can get, I suppose that's it. All right, so the top is 40t 16j equals 144. Then I have negative 16 minus 16j equals negative 42. Add these guys together and I get 34t. Did you guys notice how this is happening all the time? Notice the number that 34 is popping up all the time, isn't it? If you'd have done it with substitution, 34 is related to the answer somehow. If I divide by t here, it looks like I'm going to get 3. 34, I didn't mean to say t, I meant 34. T is equal to 3, which is actually 3.00. And now we can answer the question. Oh, listen. Find the cost for each pound of trail mix and each pound of jelly beans. Okay. So I can put, I guess I'll put it in here. The trail mix was $3 per pound. And the jelly beans they were $1.50 a pound. And there's another thing, you see this all the time in the stores. The one that I think of most often is when I go to shop for, like, say, cashews or pistachios. If you look at where you buy those things, peanuts and other stuff, the cheapest things are like peanuts. The most expensive are the cashews and the pistachios, right? So you see, don't you see a bunch of cans of stuff that have a mixture of things? Cashews and peanuts and other stuff. That's because most people won't spend $20 on a small can of cashews, but they might spent $20 on a large bag of mixed nuts. Of course, the mixed nuts, what happens? Cashews go down and the rest of them nobody eats. So you might as well just bought the cashews, I guess, and paid the money. So you can see there's an advantage to being able to use two variables, a huge advantage in setting up these word problems. Sometimes, like this last one, it was almost too easy. What was the trail mix? It was $3. I don't remember if it requires how many, if you need to put these decimals in there or not. You could just put 1.5 or not. This problem is very similar, so I'm going to let you try this. Take a few minutes to try to do this one. It is, seriously, it is very, very similar to the one we just did. In fact, when I throw it up here, would you tell me what letters you intend to use? For your variables, what letters would you intend to use? A and S sounds perfectly good to me. Advanced and same, right? Make sure you guys are working smartly. Can you tell me what equation you can get from this? That's actually a sentence all in. So what equation would that be? Can you tell me?
Plus that's equal to 55.
A plus S equals 65. You guys agree? This might be the harder part. Longer, I'll put it down here. Whoa, up there. So on the first one, we had an A plus S equals 65. Can you tell me what you got, sentence you got for the second one? What, did you get an equation for it? ticket, how much do the advanced tickets cost? So each advanced ticket is $25, so 25 for each advance plus 35 for each same day, right? And the total amount of money they got was 1,975 from that. Do you guys understand where I got that before I walk away from it? Each A costs $25. Each S costs $35. They're talking about the total amount of money made. That's why the 1975 was appropriate. Any methods that you would care to evolve that they use? I'm sort of torn too, because it's so easy to solve the first equation for substitution, but substitution doesn't guarantee. So I'm going to use elimination, and what I did is I multiplied the top equation by -5. I didn't need to bother multiplying the second equation by one's already going to have the -25 in front of it. So what do I get for these two equations? I get -25a minus 25s equals, I think this came out to -1,625. 25a is 35s 75. This way I can wipe out the a's. And it will allow me to get s fairly simple, fairly easily. I get 10 equals 300. Off the 0, we get s equals 30. So the same day tickets were $35 a piece. Now, tell me how you can go back and get day tickets. That's right. It was like, that's how many people bought same day tickets. Sorry. All right, sorry, that's my bad. Now, normally, we don't do this, A plus S, 65, and then you write the other equation. But do you see how simple it's going to be to get A? You can go back and substitute in that first equation, can't you? This is about right. It would be crazy to run elimination again when it's so simple like this. All you got to do is see in this equation, if S is equal to 35, this is how simple the equation comes out to be. And you immediately get A equals 30. So we had 30 advanced tickets. And what was the other one? 35 same day. Same, it's almost identically the same kind of problem, even if the words do look different. Even if they are doing so, this is one thing, if you really get good at math, you'll understand when problems are actually the same, but they look completely different. That is an important aspect of a mathematician, is being able to spot things like that. So I'm going to let you take a few minutes here and try this one. Anybody think they got it? What you got? That's not what I got. Let's see, look at their equations. How about, did you get any, the other two get anything? All right, well, let's take a look. Everything is contained in the sentences, not the first one, not the second one. This line here, let me go ahead and show you. Well, solution A is 45% salt. So this, everything is right here. She wants to obtain 120 ounces, right? So that means that the A that she uses plus the amount of B that she uses should add up to ounces, correct? Right, then we know that A is 45% salt, so we can write 0.45 A 0.5 B 0.85 times 100. You can survive that if you made that also an 85. So what you did, whether you know it or not, is you multiplied everything by 100. Which is okay. Did you go to decimals? So now now you got to keep in mind though, they did not say 45 anyway. They did say 45%, didn't they? That's why I put a 0.45 up there. To just put a 45, well, it will work in this case, I think is dangerous.
It's a lot bigger than multiplying with 120. That's the
Because she wanted to retain her final resultant should be 85% salt.
Right.
She wants 85% of the final to be salt, right? So the 120 ounces, she wants 85% of that to be salt. So what I'm saying is I would think that if you never wrote these decimals down, then I think you're not completely understanding. That's an issue. But you can multiply by 100 to wipe out all the decimals if you want. I didn't bother. I don't mind working with decimals. They don't hurt me. But some people can't stand the names. On the other hand, I think most people are okay with decimals because we do deal with them on a regular basis. Especially two dozen places. The other one was 0.45 Here's where the 102 comes in. That label 1 or 2. Second. .85 times 120.
So he wants mine, I guess.
Okay, this is the same, we're in the same boat we were last time. You could do substitution or elimination. I'm going to do elimination again, and I'm going to multiply the first equation by negative 0.45. Obviously, the intent is to wipe out the A's. So this system of equations next becomes negative 0.45A minus 0.45B equals, you got to do it also to the 120. 54. Oh, you didn't multiply it. Gotcha. Yeah. The other equation I didn't do anything to. Now I'm going to add these two things together to wipe out the A's. Okay, from 0.50B equals what? 48. I'm ready to finish off. How are you going with B? You're getting ahead of yourself. Now you get B. And one step. Just divide by 0.5 and multiply both sides by 2. You'll end up with B equals 96. And then, remember, A plus B was 120. So I wouldn't bother doing anything except just throw it in here. B is 96. And if I subtract 96, I'll get A equals 24. So depending on how they require you to answer the question, I don't know if they even require you units. When I was in school, if I didn't put the units on my paper, the teacher didn't give us any credit. They're hardcore in the day, I'll tell you. See, look at that. Look what they do for you. Isn't that nice? 24 and 96. Check them. Good. Number 11. Oh, I love it. Okay. One last word problem, and I will have covered all of them for the homework. There. See if you can make sense of my equations. They are not as easy. This is a more difficult style of problem. The x plus y equals 10,000. Where did I get that from? I'm going to call this equation here. This one here is my star equation. How did I get that equation? What led me to it? She's going to take for $10,000 and break it up into two pieces. Some of it's going to go into one investment, some in the other one. This is usually a smart thing to do with your money, to split up against many things. So this part right here, Heather had $10,000 to invest. That's how I came up with the equation star. Now the second equation I will call smiley face. Where did it come from? She said, there's a lot of stuff in it. An accountant paid, I'm getting it from this, and then this. Those three pieces together make up that second equation. You guys understand it? See that the point one is the 10% of A plus the 5% of B or X or Y, whatever it is I'm using. You can see it. 10% is the point one. 5% is the point, is the 0.05. But we never usually, it's not enjoyable at all to work with percentages, so they'll have to be converted to decimals. I am gonna do something, the reason I picked this, well, I don't have much time, I don't have time to let you guys go here. I'm gonna do an extremely slick method of getting rid of the X. Do you know what I'm gonna do? I guess not. You do what you wanna do, I'm gonna do a special trick. See what I did? I noticed that if I multiply the first equation by 10, it'll be X also. I just happen to notice that if I multiply 0.1 by 10, I get 1. So I use that to wipe out my X's. So I'll get 0.5y equals 4,000. Divide by 0.5 or multiply by 2 to get y equals 8,000. We'll get X then. You can see it's 2,000, right? X plus Y equals 10,000. X will end up equaling 2,000. You have to tell it though, what you can't just, like on a paper, you can't just say 8,000, 2,000. You gotta let me know which one's which. Usually I have spots just like your book does. Let's see if we have. She says the first account, I guess that's the 10% one. How much was in the 10%? Was that 2,000 was X and Y was 8,000? Check them out. And we are good. All right, that's all I have for you today. The next test does come up quickly. We're going to do one more section. We're going to do inequality stuff come on the next time. And then depending on how much time we have, we might start the review for the next exam. Turn this off.